All right, Harmony Science Academy AP Calculus students, let's go and get into section 3.4. Two problems to cover all the essential objectives, okay? Like always, we're going to try and focus on some trigonometry just for that added value. Don't make it more complex than it has to be, okay? Focus on the essentials. So this one reads like this. Find the points of inflection and discuss the concavity of the graph of the function. And our function is f of x equals 2 sine of x plus sine 2 of x in the closed interval 0 to 2 pi. Okay. So after some exposure to this section, okay, the first thing you're going to want to do, surprise, surprise, is get that first derivative. Okay. You guys can pause the video and see if you can take that derivative so you can check it. Alright, hopefully we have a match, and then of course, as you will see through this section, in this case you'll take a second derivative. Sounds intimidating, but basically the derivative of the first. Okay. So, of course, we know that in this case we would have to return it back to sine of x, but it's negative now, right? You guys have that formula sheet now, so you should feel a lot better. Alright, so remember that chain rule, so we have 2 cosine 2x. Once we run cosine 2x, take derivative of that produces another 2, and then it combines to this, okay? Excuse me. So once we're at this place, we can go and factor it out just to kind of clean it up here a little bit. Oops. And it would look something like this. Okay, if you're a little confused, look back at the double angle formulas in your formula chart on the trigonometry side, and this could be written like this. Okay, so if we go ahead and look at this, we can take out, factor it, multiplies to give us this. If we look at this form, right, so this is essentially here times 1. Out of this portion, if we take out the negative 2 sine x, right, we're left with 4 cosine x right here. Okay. All right, again, that is specific to this trigonometry, not to the lesson of the day, okay? So if you can do this, you're fine. So now let's go and continue. And again, as you flow through this section, you'll realize, like always, you want to see where, well, not like always, but in this case, you're interested when this double derivative, okay, the second derivative equals 0, okay? And when does that happen? Okay, that happens at specific x's. So we know, right, if we were to set that equal to 0, it definitely happens when sine, or the angle measure, is 0 and 2 pi. We know that for a fact, so those are going to go in there, right? That would make this 0 times anything would make it 0 as well, okay? Now, as far as this expression in here, okay, I'm going to have to rely on the calculator on this one because it doesn't have the really nice dimensions we're used to. But if you're following along, you set this equal to 0, subtract 1, and then divide by 4, right? So you've got cosine x equals negative 1/4. So it's in this region, right? Negative 1, so 1 to the left. And then you've got R4, so something like that, right? 4, about negative 1 this way. Okay, so you've got something going on here. And then at negative 1, you can also get an R going this way. Okay. So you're going to end up having 2 additional values that can produce that. So I went ahead and punched it in the calculator to save time. I'll just kind of show you what those values are. but in class you guys can ask and we can look at how to set that up, okay? Alright, so let me go and include them on here. And again, I try and avoid the calculator as much as possible, but in this case, I didn't have much of an option, okay? 4.46. Alright. Next up, let's go ahead and... Alright, I have issues there with the recording. We're back on track. Alright, so now what we're going to go ahead and do is create these intervals. Okay, so we can ultimately find the points of inflection, discuss the concavity, okay? So, how do we set this bad boy up? Let's go ahead and TI for the test interval, okay? We'll put the sign of the second derivative, and lastly the conclusion, okay? So let's go ahead. Let's see if I can draw a straight line here. Alright. So the first one goes from 0 1.82. Sorry for the sloppy write, I'm trying to speed things up here. And we'll get to pi. We'll go to pi to 4.46. And lastly 4.46 to 2 pi. Okay. So at this point, we've pretty much taken care of everything. Well, what we want to go ahead and do is test specific values that are convenient within those intervals. Okay, I'll kind of sheet the system here and just reach the conclusion. Okay, you guys can actually play with the specific values you'd like, but since you have a calculator, plugging in there will do all the work for you. Okay. So based off of this, right, and the reading in the section, you would conclude that this is what concave downward. Okay, this one would be concave upward. This one would be concave downward and concave upward. Okay. So where do we go from there? We've got that component. Now as far as points of inflection, right? Points of inflection, we'll abbreviate as such. We can say it's happening where? 1.82. And what's this last one? 4.46. Negative 1.45. Okay. Of course, these are the values for the x-coordinate. This is the y value once you plug it in the calculator. So let's go ahead and move on to the next one. Okay, and before we do jump into the next one, notice that how do you know you've got point of inflections? Again, once you do some careful reading, anytime you've got this concave downward and then now you've got an upward, it makes this guy a hot spot, point of inflection. Same thing happens here from up to down and here from down to up. So it's these values here. Okay. And then just plug in and come up with the corresponding y coordinate. Alright, let's move on. This one reads like this. Find all the relative extrema. Use the second derivative test where applicable. Okay. Okay, this one, it's a lot simpler of an example because I want to make sure we really hit the objectives. So let's go and get started, right? Find all relative extrema. Use the second derivative test where applicable. You've got f of x equals x minus 5 that squared. Okay. So the first thing we're going to go ahead and do when we approach these is take that first derivative. You can pause the video here again, see if you can beat me to the punch. Good. If that's what you got, awesome. Next up, let's go and take that second derivative. And if you've got 2, great. Okay. Now, as far as critical numbers, okay, we'll put critical number. That's going to happen at x equals 5, right? So that's familiar territory to us. And now we use that critical number in the second derivative. Whoops. We're going to plug it in there. And we notice that it is indeed what? Positive. Okay? Or greater than 0 is the way we can abbreviate it. Therefore what? We can say that 50 is a relative minimum. Okay, and that'll come as a consequence of that theorem once you guys get your eyes on it. Appreciate your time. Hopefully the video wasn't too long. We'll catch you in the classroom, okay?